Hi, let's take a look at the ambiguous case of the law of sines. So what that means is we can use the law of sines to calculate for a missing angle when we have two sides and a non-included angle. However, when we do that, we get a situation where we can either get two possible answers that are correct, or in some situations there's no possible answer that's correct. So we're going to take a look at these different situations and how they arise and try to make sense of this. So let's take a look visually how the law of sine can give us an ambiguous answer, give us two different answers for the same question. So if we're using the law of sines and we're given two lengths of sides, so the blue and purple at a fixed length, and we're given an angle, but not an angle that is included in those. We're talking about an angle that is opposite one of those sides, and we got to find the angle that is the included angle between those. So if we take these two sides, that's going to be part of the triangle. The angle over here, because it's not an included angle. And then the line, the third line, in order for that angle to be true, we've got to have the third line be along this line. So then keeping the blue line the same length, we could move it anywhere along this path. So if we move it down to meet the dotted line here, that's one triangle that can be formed with these two lengths and this angle. But that's not the only one. We could continue and move this down along that arc a little more. And this is another one that still has the same measurements and the same angle as well. So that visually demonstrates how we can get, given two sides and a non-included angle, how we can get two different values for this angle. So it's also possible using the law of sines to get a situation where we have no solution. So let's do the same problem again. We're just going to change it slightly right here. We're going to change the length of one of the sides. So again, let's form the triangle with these two sides, the purple and the blue side. We have a non-included angle right here, and that means the third side needs to go along here. So we can rotate that blue line anywhere along this arc, but you can see as we try to meet the dotted blue line, the blue line just isn't long enough to get there. So in this situation we have no answer. There is no triangle that can be formed. So let's start. There's 6 different situations. All of them kind of follow the same logic. So let's put some labels along here. Let's do sides A and B. The angle opposite A will make a capital A. And then we're going to throw the height in there because the height becomes important as well. So going back to the first problem we did. So the first thing we looked at all acute angles, right? So these are the 6 different situations. So we looked at acute angles to start with. So the first problem we did is when we were able to form two different triangles, and that happened when we had an acute angle and A was less than B. So if A is less than B, then we hit the dotted blue line in two different places and we got two triangles. But if A was actually longer than B, we wouldn't have hit 2 before we got over here, right? We wouldn't have hit the blue line twice. So this only forms 1. So if we have an acute angle and A is greater than B, then we only have one such triangle. Now the one we just looked at here, if we have an acute angle again and it's too short to go all the way down to the blue line. In other words, it's shorter than the height. We put the height in there. So if the blue line is shorter than that, then we can't make a triangle. Now if it's exactly right and it's just the length of H, it's just going to touch right there and make one little triangle. So that right there we can do is if A equals H, then there's one triangle that exists. Now those 4 we did with acute angles. Now let's see, what if this angle changes to become an obtuse angle, larger than 90 degrees? Well, there's 2 different situations. If A is greater than B, we can rotate A around, but there's no other place that we can make a triangle. We can only make this one triangle where it touches here. So if angle A is obtuse and A is greater than B, then there's only one such triangle. But if angle A is obtuse and A is less than B, then again we have the situation where it's just too short to complete the triangle. So in this case, there's no triangles that exist. Thanks for watching. If you haven't subscribed yet, you can do so right over there. And if you like what you see and you want to watch more, I've got another suggestion for you right over here. Thanks for watching.